Dumelang, sanibonani, molweni, abusheni, nda, hello, goeiemorgen, everyone. Please hit the like button, subscribe, notification bell, share. Masenze lezo nje before siyakude, right? As course the next man wenze mahalash. Okay, and then from here, let's go to the question of the day. This is mathematics grade 12. Start the number patterns today, part 3, right? Okay, so the first question says you are given a geometric series. We know it's geometric, so we know division and multiplication as semenzalana. To get the next time you multiply. So but is 3 plus 6 plus 12, right? To n terms. Write down the general term of this series. General term is grade 11 work. Again. So 3.1.1. General term, a geometric series, Tn is equals to a r to the exponent of n minus 1. Okay. So our Tn will be equals to Ea is our first term, which is 3, and then our r will be our constant ratio. How do we find the constant ratio? We say term 2, which is 6, divided by term 1, 3, should be equals to term 3, which is 12, divided by term 2, 6. So this side should be equals to this side. 6 divided by 3 is 2. 12 divided by 6, 2. Our general ratio is 2. So we have 2 to the exponent of n minus 1. So we have found our general term. Guys, that part should be easy. That part should be grade 11. If still we understand, go to my grade 11 videos, Zama sequence and series. I just posted one up, and then get a refresher course, right? Okay, from Lapo, we go to the second question, which is 3.1.2. Remember, some confiance, 2 things we don't miss. We read the instruction, which is very important. And then number 2, we number correctly. So the second question says, calculate the value of k such that the sum, not too silent, it's just a sigma notation for sum. If I don't know Sn, right? So which is by playing alphabet is Greek. That's the only difference. So the sum of that equation and p is equals to 1. Equation expression 3 over 2 multiplied by 2 to the exponent of p, now p is equals to 98,301. So the answer layala, right? So bas p p where to column 1, right? Meaning we can expand this to a sequence with number. So p is substituting 1, then 2, then 3, then it's a sequence, right? So when we do that, that kule spell lesa 3 over 2 times 2p uzofaka u1 la ku-p bese i-answer yakho kuzoba u3 mawufaka lonke lento calculator, bese uzofaka u2 ku-p bese i-answer yakho kuzothi u6, bese uzofaka u3 ku-p bese i-answer yakho izothi 12, and then it gives you a sequence, right? We are looking for a sequence. We must find k. K meaning what? How many terms are there? So we are looking for n. K represents n, because every time you are looking for a number of terms, number terms, you are looking for n, right? So they gave us what it equals to 98,301. Now when you look at our sequence, if you try to minus t2 from t1, it will give you 3. If you try to minus t3 from t2, it will give you 6. So it's not an arithmetic sequence. But if you divide, it gives you 2 and 2, meaning it's a geometric sequence. So you are going to use the sum formula, but for a geometric pattern. So if formula corner is Sn a r to the exponent of n minus 1 close bracket all over r minus 1, and remember r cannot equals to 1, because if it's 1 by 1 it's 0 undefined. There's a story here. So mathematically grade 12 r cannot equals to minus 1. Ngizwile ngithi mathematically grade 12, meaning ukuthi mawufika kwamanye ama level singakhuluma esinye story mama siyeke le. Okay, so my substitute density is equals to a wethu, which was 3 now a, and then open bracket r wethu, which is 2. We already said t2 divided by t1, which is 2. n wethu, which is k minus 1. So substitute t lana all over r wethu, which is 2 minus 1, right, which will be equals to, so this is substitute we can equate it, because they've already told us what our sum is equals to 1. So we have 3 big bracket 2k minus 1 all over 2 minus 1, which is 1, which will be equals to 98,301. Measure from lana, we just solve. 2 minus 1 is 1, so layer ES18. So we'll be remaining with 3, open bracket 2 to the exponent of k minus 1 is equals to 98,301. Divide along with 3 is for keep out 3 card in a pandle, keep out in the bracket. And then we have 2 to the exponent of k minus 1, which will be equals to 32,769. Basis transposer, 67. Basis transposer low 1. So it's 2 to the exponent of k, which is equals to 32,767 plus 1. And it must transpose is any change. So we have 2 to the exponent of k, which will be equals to 32,768. Now, if possible, the calculator can help you with this. Try to find this number in terms of 2, if possible 2. If you put it to calculator, uthi le number le ufuna ifactor yakhona, there's a button lapho u-k ripple effect, ufake leyo to, then you find ukuthi 2k is equals to 2 to the exponent of 15. It will break this number down to an exponential form. Ama base ayafana, we drop them. Then k will be equals to 15, which therefore means k wethu we have 15 terms kulesibalo le, which is what we were supposed to find. So in number ephezulu sigma notation, let's go back to a sigma notation. Ingan2 is a sigma notation. It's just to Sn written in Greek form. That's it. Why by yenza, no one knows. So la it tells you what term engaki. So must solve the question level says what term I15 will a series, right? And then OP was of substitute to abanye. Then you just use your normal formula. It's not that deep. It's not that deep. Okay. Now let's go to the last question. When we go to the last question, dwelling is slow, right? It says a geometric sequence, it is by geometric sequence and an arithmetic sequence have the same first term. So it is by when I'm a sequence I2 which share the first same term. The common ratio of the geometric sequence is 1/3. Okay, that's the first term. That's the common ratio. The common difference of an arithmetic is 3. Okay, Why important, the common ratio and the common difference? So we can find the other terms, right? We can, because you can just multiply by 1 over 3, multiply by 1 over 3 to find the others, and then you can plus by 3 to find the others for arithmetic. They didn't give us a value for a geometric sequence or arithmetic sequence. They just told us it's the first same term. So it's x, let's call it x. The sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity of the geometric sequence. So they are also telling us what the sum of the 22 terms. So the arithmetic sequence has 22 terms, and they give you 734. That's information. I mean 734 more than, so greater than the sum of the infinity of the geometric sequence. Hey, Manjelana, we must break down the English, but I think we've broken down most of it, right? Now let's break it down mathematically. Let's try it in here. Okay. So one thing for sure is here 0, which we have the sum of 22 terms, right? The arithmetic sequence, and we know a familiar arithmetic sequence is n over 2 open bracket 2a plus n minus 1 close bracket d, right? So must we substitute that? It will be 22 over 2 open bracket 2 times a, because we don't know a, but challenge which is the same as geometric and length. They share the same a, which will be n minus 1 close bracket common difference but 3 arithmetic. So they actually gave us a lot of information, right? And then from here we simplify this, and then S22 becomes 22a of our calculator, or we solver, plus 693. So we have our first formula, which is the one here, arithmetic sequence. Then they told us about S to infinity. That's the other thing about sharing. And they told us about the general term. So if formula S to infinity is a over 1 minus r, and remember, r cannot equals to 1, because then it's a mess. So must we substitute to a as maznala. The only thing we know is the ratio, and they said it's 1 over 3. And then when we solve this, it gives us 3 over 2a. So we have two expressions, one here geometric, the other one here arithmetic, and then they all have a. Now from here we can equate the two to find a, because remember they said they have the same first term, meaning a waga geometric is the same as a waga arithmetic. So when we equate the two, we shouldn't forget the English. So we have 22a plus 693. This is our first term, and then we have 3 over 2a plus, remember they said arithmetic is 734 more than a geometric to infinity. So this is geometric to infinity, and then we'll add 734 because they said it's more than, so it's plus 734, right? And then from here, is number a one side, is number a one side. Before speaker lapo, we have to take out low 2, right? In order for us to take out low 2, we must multiply everything by 2 times 2 times 2. What you do on the left hand side, you do on the right hand side. So everything times 2. 22 times 2 gives us 44a, plus 963 times 2 gives us 1286, which is equals to less about 2 by cancel. We have 3a, and then plus 734 times 2, which gives us 1468. After we are done here, Abu A one side, then an Abu A one side. So we have 44A transpose the 3A similar to our push to minus 3A, and it will equals to 1468. Transpose the local number, which will be minus 1386. Then math is solved. We have 41A equals to 82. Divide by 41, divide by 41. So no A by 1 in it, and then A will be equals to 2. So our answer for the first term Yama sequence Yama arithmetic geometry is A is equals to 2. So you can now draft your sequences, but they didn't say we must write down and find a sequence. They just said they want to know what will be the first term. So that's how you do it, guys. We take the information, that English meaning, we make equations out of the English, then we try to come with a logical way to get to a logical answer. Right? Okay, guys, thank you for joining me for this part of the session. Please follow, like, subscribe, and share, importantly. And then if you want the one-on-one session, maybe specific questions on a specific topic, please contact us kusankofa@gmail.com. First 10 learners, pupils, will get a free session. And then after that, we'll inform you when you contact us. It's not that expensive. It's 50 rand per session, and then it can get you ready to pass the maths, right? Okay, guys, sharp.